Okay, Wildcats, today we're at journal page 36, characteristics of quadratics. Okay, so when f of x equals ax squared plus bx plus c, it opens upward. Here's your y-intercept. It has a vertex, which is a minimum, and your axis of symmetry is the h value of the vertex. The domain is negative infinity to positive infinity. The range is y is greater than or equal to k. Now, if f of x equals negative ax squared plus bx minus c, it opens downward. Your vertex is a max, and the h value of the vertex is your axis of symmetry. The domain is negative infinity to positive infinity, and the range is y less than or equal to k. All right, vertex form. Y equals a parentheses x minus h squared plus k. The vertex is h comma k. The axis of symmetry x equals h. When the a value is positive, the direction is up, and the vertex is a minimum. When the a value is negative, the direction is down, and the vertex is a maximum. Standard form is y equals ax squared plus bx plus c. The vertex is h equals negative b divided by 2a, and k equals f parentheses of negative b divided by 2a. The axis of symmetry is x equals h, which is equal to negative b divided by 2a. Okay? When the a value is positive, the direction is up, and the vertex is a minimum. When the a value is negative, the direction is down, and the vertex is a maximum. If you would, go ahead and finish up your notes. Okay? And adjust this here. There we go. All right. All right. Write the equation using key attributes in standard form, vertex form, and parabolic form. Identify the characteristics of the parabola. Okay. Now, let's do the vertex in blue. So that's your vertex, which is, in this case, 1, 1. Okay. Now, our axis of symmetry cuts the parabola in half. Okay. And it's the h value of the vertex. So x equals 1. Okay. This opens upward. And the y-intercept is here, and so that is 0, 2. Now, if it opens upwards, it's a minimum, and it's the y value of the vertex, so y equals 1. Domain, we know from our notes, is negative infinity to positive infinity. And range, we know, is greater than or equal to, but we want to write that in interval notation, so that's brackets 1 to infinity. Okay, so go ahead and finish up example 1. All right, let's take a look at example 2. All right, so our vertex, which is right here, which that point is 4, 9. Now our axis of symmetry cuts the parabola in half, so that's right here. And it is the x value of the vertex, so x equals 4. it opens downward. Okay. And then our y-intercept, it looks like, is right here. So 0, -5. Okay, if it opens downward, it's going to be a maximum, and that's the y value of the vertex. So y equals 9. Okay, domain we know is negative infinity to positive infinity. The range would be negative infinity to, looks like, comma 9 bracket. All right, go ahead and finish up example 2. All right, example 3. Okay, now the vertex, which this is your h, that's your k. So the vertex is 1, comma, -3. And the reason is because that's y equals 2 parentheses x minus h squared plus k. So that's why the h is just 1 and the k is -3. Okay. Now the axis of symmetry is really simple. It is the x value of the vertex, so x equals 1. Now we know because the a value here is positive, it opens upward. Okay. The y-intercept is when x equals 0. So you're going to substitute 0 in for x, solve for y. So y equals 2 parentheses 0 minus 1 squared minus 3. So then that's y equals 2, -1 squared is 1 minus 3. So 2 minus 3 is -1, so y equals -1. Let's try to straighten our work out a little bit. So your y-intercept is 0, comma, -1. I got a little blurry there. Okay. Now, if it opens upward, it's a minimum, and it's the y value of the vertex. So y equals -3. Domain's real simple. It's negative infinity to positive infinity. And range would be brackets -3 to positive infinity. Okay, go ahead and finish up example 3. All right, example 4. Now, to find the vertex, this is a little bit more difficult. Okay, what we're going to need to do is identify that A equals -3, B equals 12, C equals -10. And then we're going to use this note right here. Now, I use lowercase b and lowercase a, but in essence, I'm going to use capital B and capital A to help the work a little easier, okay? So, H equals -b, so that's -12, divided by 2 times a, which is -3. So that's -12 divided by -6, so h equals 2. Now, to find the k value, you're going to substitute 2 into the function and solve. In this case, it's not going to be y, it's going to be k. So k equals negative 3 times 2 squared plus 12 times 2 plus 10 equals 2. Remember that how small. Let me write that. Negative 3 parentheses 2 squared plus 12 times 2 plus 10. Okay, so the vertex is 2, 2. Okay, now the axis of symmetry is the x value of the vertex, so x equals 2. Okay, now because the a value is negative, we know it opens downward. Now to find the y-intercept, that's when x equals 0. So we're going to substitute 0 into the equation. So y equals negative 3 times 0 squared plus 12 times 0 minus 10. Well, that's 0, you're left with negative 10, so y equals negative 10. So your y-intercept is 0, negative 10. Okay? Now, if it's opening downward, it's a maximum, and that's the y value of the vertex, so that's y equals 2. Domain, again, real simple, negative infinity to positive infinity, and the range would be negative infinity to 2 bracket. Oh, sorry, let's fix that. All right, vertex. Okay. Now, again, we need to identify what A is. This is 1, so A equals 1, B equals negative 18, C equals 86. Now, I'm going to write this out on a note card here for vertex so you can see it to work a little bit better. So to find the vertex, okay, we know that H equals negative B, so that's negative 18 divided by 2 times the A value, which is 1. So negative 18, well, that's actually positive 18 divided by 2, which is 9. Okay. Now to find the K value, you put 9 back into the equation. So K equals, and I'm writing it bigger just in case you weren't able to see that clearly. So it's the same process here. So K equals 9 squared minus 18 times 9 plus 86. Which K equals 5. So what I'm going to do is just cut this and then with some tape, going to add that, and so then I can flip that over, and then I can just write the vertex underneath. Okay, which the vertex is 9, 5. Okay, so the axis of symmetry is the h value, vertex of x equals 9. Okay, and then it opens, the a value is positive, so it opens upwards. The y-intercept, again, was x equals 0. So we're going to substitute 0 into the equation for x. So y equals 0 squared minus 18 times 0 plus 86. Well, that's 0, you're left with y equals 86. So your y-intercept is 0, 86. All right, if it opens upwards, it's a minimum, and so y value of the vertex, so y equals 5. And then the domain, again, is negative infinity to positive infinity, and then it will be bracket 5 to infinity. Now, at this point, if you're good with this and you're able to read that, stop the video. You're done with the example. Start working on assignment. If this was hard to read, I'm going to add a few minutes to this video so that I can rework example 4, at least for the vertex. I'm going to add it here in a note card like this so you can see it, okay? So again, if you got this, you're good. Stop the video, start working on assignment. Now let's go through this here. Write that a little clearer, hopefully to see. All right, so let's look at the vertex for example 4. Okay, so we know that h equals negative the b value divided by 2 times the a value. Okay, so that's negative 12 divided by a negative 6, which equals 2. And now we're going to substitute that value in for x and solve for k. We're going to change y to k because that's what we're looking for. K equals negative 3 times 2 squared plus 12 times 2 minus 10. So k equals 2. And again, let's just add this to here. Make sure it's slid over just slightly. Right there, there we go. Add that there, and then the vertex is 2, 2. All right, so with that, if you would, go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.